Novel method for adaptive filter algorithm with shadow mechanism for speech signal. Abstract adaptive filters are successfully using in cancellation of echo and noise signals in signal processing, radar communications and in speech communication systems. Here we are proposing an adaptive filter with LMS algorithm based on shadow concept, which is useful for the cancellation of the noise component overlap with speech signal in the same frequency range, but fixed LMS algorithm produces minimum convergence rate and fixed steady state error. So we presents design, implementation, and performance of adaptive FIR filter, based on shadow concept, which produces minimum mean square error compared to fixed LMS, and we also obtains denoised speech signal at output, and also we propose to calculate SNR values of adaptive filter with LMS algorithm with and without shadow concept. And also observe the output for adaptive filter using LMS and RLS algorithms. Keywords: adaptive algorithm, LMS algorithm, RLS algorithm, shadow concept. Adaptive filters. An adaptive filter is a system with a linear filter. Adaptive filters are successfully using in removal of artifacts presenting in ECG signal 1. It has a transfer function which is controlled by variable parameters and a means to adjust those parameters according to an optimization algorithm. These optimization algorithms are complex, and because of that almost all adaptive filters are digital filters. The performance of active noise control system which uses linear adaptive filter algorithm was degraded by the nonlinear saturation too. Adaptive filters are used in devices that are mobile phones, other communication devices, camcorders, digital cameras, medical monitoring, etc. The LMS algorithm is widely used in many applications as an effect of its simplicity and robustness. 3. Filters with adjustable coefficient are called adaptive filters. Although both FIR and IIR filters have been considered for adaptive filtering, but FIR filter is commonly used. Various adaptive filter denoising methods were analyzed with modulated signal as reference signal to achieve a better SNR. 4. Adaptive filters provide performance excellence due to their inherent pole zero structure as compared with adaptive finite impulse response, FIR, filters that have an all-zero form, in active noise control application. 5. The stability of filters depends critically on the algorithms for adjusting its coefficients. RLS filters. 6. The adaptive filters are widely used in areas such as control systems, communications, signal processing, acoustics, and others to deal with random signals with stationary or quasi-stationary statistics. 7. And adaptive filters are using in neuroprocessing systems. 8. Adaptive noise cancelling is used for the noise cancellation, and it is produce a signal that is equal to a disturbance signal in amplitude and frequency but has opposite phase. These two signals results in the cancellation of noise signal. LMS-based adaptive filters used in all sparse systems for noise cancellation. 9. Adaptive LMS filters are employed in the design of mechanical, electronic systems. 10. Adaptive filtering technique has been shown to be useful in many biomedical applications. 11. Shadow concept. In shadow filter mechanism uses two filter, one is in forward path and second one is feedback filter. By this arrangement the spectral characteristics forward path filter improves by varying the shadow factor. Shadow mechanism is successfully used in improving the spectral characteristics of Windows 12. Shadow-based filters are used in cardiac signal processing for elimination of noises. Shadow mechanism interprets window characteristics which are used in the design of FIR filter. And also it is used in the design of tunable FIR filter. Shadow-based filters are used in cardiac signal processing for elimination of noises. 13. Design of adaptive filter with fixed LMS algorithm. The figure 1 shows the block diagram of adaptive filter with fixed LMS algorithm which processes the noised speech signal through it. Where? Result and implementation. We implement these algorithms in MATLAB by using MATLAB codes for adaptive filtering. The figure 3 shows the response of the adaptive filter with fixed LMS algorithm with shadow concept. And we applied a noise signal to speech and compare the signal to noise ratio of noised signal before and after the filtering for Kaiser window. When the noised speech is filtered with adaptive filter with fixed LMS algorithm, the whole noise was removed, producing a near clean signal with different values of shadow for filter for Kaiser window. SNR, steady state error are computed for adaptive filter based on without shadow and with shadow concept. The results also show responses of the adaptive filter with LMS and RLS algorithms. The above figure 4 shows the denoised speech at the output for equals 0.1, 0.2, 0.3. The figure 5 shows the denoised speech at the output for equals 0.4, 0.5, 0.6, and the figure 6 shows the denoised speech at the output for equals 0.7, 0.8, 0.9. The below figure 7 shows the response of adaptive filter of LMS, least mean square, algorithm. And we also show the response of adaptive filter for RLS, recursive least square, algorithm as shown in figure 8. Window was performed and show response of shadow adaptive filter from figure 3. We also observed response of shadow adaptive filter for different shadow factors as shown from figure 4 to figure 6. We compared SNR, mean square error, MSE, at input and output, which are shown from table 1 and table 2. Later we show the response of adaptive filter by using LMS and RLS algorithms as shown from figure 7 and figure 8. From the above discussion, it is concluded that shadow-based fixed LMS adaptive filter produces better responses in terms of SNR and MSE as compared to adaptive filter using LMS and RLS algorithms.